Hey gearheads, ever wondered what makes those wheels turn? It all starts with the heart of the machine, the internal combustion engine. This incredible invention powers everything from our cars to motorcycles, boats, and even lawnmowers. It's a symphony of controlled explosions transforming fuel into the energy that keeps us moving. Imagine a small, contained explosion happening thousands of times per minute. That's the basic idea behind an internal combustion engine. We take a mix of air and fuel, ignite it inside a closed chamber, and harness the energy released. This energy is then used to drive a shaft, which ultimately turns the wheels and propels us forward. The beauty of the internal combustion engine lies in its simplicity and efficiency. With just a few moving parts working in perfect harmony, it has revolutionized transportation and countless other industries. So, let's pop the hood and take a closer look at how this marvel of engineering actually works. The internal combustion engine operates in a continuous cycle, repeating 4 distinct steps: intake, compression, power, and exhaust. Think of it as a perfectly choreographed dance, with each stroke playing a crucial role in the engine's performance. It all begins with the intake stroke. The engine breathes in a precise mixture of air and fuel, much like we inhale oxygen. This mixture is then drawn into the engine's cylinders, preparing for the next stage. Next comes the compression stroke. Here the piston moves upwards, squeezing the air-fuel mixture into a much smaller space. This compression is vital because it increases the energy potential of the fuel, making the upcoming explosion much more powerful. The third stroke is where the magic happens, the power stroke. A spark plug ignites the compressed air-fuel mixture, causing a controlled explosion that pushes the piston back down with tremendous force. This downward motion of the piston is what ultimately powers the engine. Finally, we have the exhaust stroke. The piston moves back up, pushing the burnt gases out of the cylinder and into the exhaust system. This clears the way for the cycle to begin anew, with the intake of fresh air and fuel. This continuous 4-stroke cycle repeats thousands of times per minute, creating the power that drives our vehicles and powers our world. Now that we understand the basic 4-stroke cycle, let's meet the key players that make it all happen: the cylinders, pistons, spark plugs, and crankshaft. These essential components work together seamlessly, like a well-oiled machine. First, we have the cylinders. These are cylindrical chambers within the engine block where the 4-stroke cycle takes place. Each cylinder houses a piston which moves up and down, compressing the air-fuel mixture and harnessing the energy released during combustion. The spark plug plays a crucial role in igniting the air-fuel mixture. Positioned at the top of each cylinder, the spark plug delivers a precisely timed electrical spark that initiates the controlled explosion during the power stroke. Connecting the pistons to the engine's output is the crankshaft. This ingenious component converts the linear up and down motion of the pistons into rotational force. Think of it like a bicycle's pedals and crank arms, transforming our leg power into the spinning motion of the wheels. The coordinated movement of these components within the engine is a marvel of engineering, converting fuel into usable power with remarkable efficiency. But how does air and fuel actually create energy? The answer lies in the chemical composition of fuel and the process of combustion. Fuel, such as gasoline, is packed with energy stored within its chemical bonds. When mixed with oxygen from the air and ignited by the spark plug, a rapid chemical reaction occurs. This reaction, known as combustion, releases the stored energy in the form of heat and expanding gases. This rapid expansion of hot gases pushes the piston down with significant force, providing the mechanical energy that drives the engine. The heat generated during combustion is a byproduct of this energy conversion process. The efficiency of an engine is determined by how effectively it can convert the chemical energy stored in fuel into usable mechanical energy. Engineers are constantly striving to improve engine designs and optimize combustion to extract the maximum amount of power while minimizing fuel consumption and emissions.